Okay, so before I go through some examples, I'm going to kind of give a brief explanation on these. So when you're adding and subtracting fractions, which rational expressions are just fractions. So say that I was adding 1/2 plus 3/4. So in order to add or subtract, only adding and subtracting fractions, you have to have a common denominator. So if you look, the denominator or the bottom, these are different here. So if you have 2 and 4, I have to make them the same. So really, if that's 4 and that's 2, then all I have to do is times this by 2, and I'll get 4. And if I times the bottom by 2, then I have to times the top by 2. So then I'm going to have 2 times 1 is 2. 2 times 2 is 4, which 2 over 4, 2 divided by 4 is the same thing as 1/2. So yeah, we did that right. And then 3/4 would equal 5/4. So you just add up those. 2 plus 3 is 5, and then the bottom stays the same. So that's how you always add fractions. Now if it were subtraction, it'd be the same thing. So let's say that I had 3/7 minus 2/8. So if I have 3/7 minus 2/8, then here I'm just going to have to find a like denominator or common denominator. And in order to do that, really, you could just multiply those together. So back here, we could have multiplied these together and gotten 8 as a common denominator, and that would have been okay. We just would have gotten 10/8, which then you'd reduce to 5/4. So it doesn't matter how big it goes. So 7 times 8 would be 56. So the bottoms are going to be 56. So to get that, I'm going to times this by 8, and this by 8, and this by 7. So you just multiply by the opposites. So then I get 24/56 minus 14 over 56, and then I do 24 minus 14 is 10, and then that would reduce to 5, and then 56 divided by 2, that's 25, 28, I think. So 5/28, and that would be your answer. Okay, so that is for adding and subtracting fractions. So hopefully that makes sense. Now, a rule of fractions is you cannot have 0 on the bottom. So if you had 1 over x, you would say, hey, x cannot equal 0, because you can never divide by 0. And if you put it in your calculator, it would say like undefined. So the bottom can never be 0. So if I had 1 over x plus 5, then I would say, hey, what would make this equal to 0, since it cannot equal 0? So x plus 5 equals 0. Well, then I'd minus 5. So then x, that goes away, equals -5. So then we'd say, hey, if this were it, x cannot equal -5. And that would be part of your answer. And then if they had something, if it started something like this, 2x plus 7, so it does not matter what's on the top, and it factors out to x minus 8 and x plus 2. Then what could the denominator not equal? Or what would be what they call the restricted domain, meaning what can x not equal? That's all it means. So x cannot equal. Now let's find a pattern going back to this one. So if you have x plus 5, well then they just did the opposite. So the opposite of positive 5 is just -5. So x cannot equal positive 8, and x cannot equal -2, because that's the opposite of those. Now, if it had something like crazy on the bottom, so like 3 over 2x minus 3 is one of them, go ahead and just set it equal to 0 and solve that. But when it's just x minus 8, makes it easy. If this one, you'd have to add 3. So 0 plus 3 is 3, divide by 2. So x could not equal 3/2. So the trick with this, it's the opposite of this, divided by that. Okay, so that's going to be the intro, and then I'm going to do examples on another video, so it's not super long.